Miss Wakefield, do you remember the event of January 14, 2019?
Yes, the car crash. So, I was just driving my truck normally, and then there's an intersection. So I started to slow down, and I was going 15 miles per hour, or 6.7 meters per second, and I made sure of that. And then Mr. Garcia, he's driving, and he doesn't even stop at the flashing red light. So I'm over here, doing what I'm supposed to be doing, slowing down, and he comes out of nowhere and doesn't stop. So, it's his fault. And I have my calculations to prove it. So, first, I calculated the coefficient of friction between Mr. Garcia's car's tires and the road. So I got 100 over 130, so the coefficient of friction between his tires and the road was 0.769. So then, I calculated the acceleration of his car while it was skidding. So A equals mg, so I got 0.769 times 9.8, so his acceleration was 7.538 meters per second squared. So then, I calculated the velocity of his car after the crash. I got 0 squared minus negative 7.538 times 8.2 times 2, which came out to be 11.12 meters per second, and that was his car's velocity after the crash occurred. So then with that, I used the conservation of momentum to determine what his car's initial velocity was before the crash occurred. So I got m1 times v1 equals m2 times v2. So I plugged that all in, and I got 1,388 times his initial velocity of the car over 1,388 equals 1,388 times 11.12 times sine of 32 over 1,388. So what I concluded was that his car's velocity before the crash was 12.78 meters per second, which obviously means he didn't stop. So it's his fault. He crashed into me. He was going too fast.
Thank you. Hello, Mr. Garcia. Do you remember what happened on January 14, 2019?
Okay, yeah. During the crash, it was not my fault at all. It was all Miss Wakefield's fault, okay? I made a complete stop before going into the intersection, and I also saw Miss Wakefield speeding, and she didn't slow down before coming to her intersection. So, I also have my calculations to prove why I was right and she was wrong. So, to figure out the coefficient of friction between the car tires and the ground, I used the coefficient of friction that she calculated for the car, and I multiplied it by 0.7, which was supplied by the Houston Police Department, and I got the coefficient of friction to be 0.538. Okay? So now, to find the acceleration which the car was going at while it's skidding, I multiplied the coefficient of friction times gravity, and I got 5.277 meters per second squared. Now, to find out how fast she was going, after the collision, I used the kinematic equation, and it's the square root of 0 squared minus negative 5.277 times 11 times 2, which I got her final velocity to be 10.77 meters per second. Okay, now I'm going to use the conservation of momentum to show how fast she was going before the collision. So 7,112, which is the mass of her truck, times the velocity over, and I divided that by the 7,112, the mass. And on the other side of the equal sign, I have 7,112 times the velocity, 10.77, times the cosine of 7. Divided by the mass that I got from this side. I got the velocity before the collision to be 12.51 meters per second.
You both calculated your velocity before the crash, so prove to me why each other was wrong. I used kinematic equations as well. I used the distance between the crash site and the light, and the acceleration that you were going at to find what your speed that you should have went at before the crash, which is lower than our calculated speed. So I can tell that you were not stopping at the light. And also,
Exactly. If he was supposed to stop, he should have been going 8.831 meters per second.
Let him finish.
But you're not out of this either.
Exactly.
I showed you all my calculations.
You claim to be going 6.71 meters per second. We got that you were going 12.51 meters per second, meaning you were not going at your stated speed as well. You are both at fault and you are both liars.